Okay, so are you able to tell the first 20 elements in the periodic table? Justin, can you tell me? Justin, can you tell me the first 20 elements? Huh? Can you hear me? Said, can you tell me the first 20 elements? Tell me yes or no. Said, can you hear me? Okay, Ajarlin. Yeah. Did you tell the first 20 elements in the last class? Yes, right? Okay, so Adulya, can you tell me first 20 elements?
Yes, ma'am.
Okay.
Hydrogen,
Yeah.
helium,
Yeah.
lithium, beryllium, boron, carbon,
Yeah.
nitrogen, oxygen, fluorine,
Yeah.
neon, sodium,
Yeah.
magnesium, aluminium,
Yeah.
silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium.
Yeah, that's the first 20 elements. Okay. So what about this atomic number and mass number? Sania, can you hear me? Sania.
Yes, ma'am.
Yeah, what do you mean by this atomic number?
It is a number of protons and electrons of an atom.
Yeah, number of protons or number of electrons of an atom. Fine. Then what do you mean by this mass number? Ashik?
Yes, ma'am.
Yeah, what do you mean by mass number? Can you switch on your video? Yeah. What do you mean by mass number? Tell me. So sum of, yeah. So
Sum of atomic mass.
Sum of protons and
Neutron.
protons and neutrons. Okay. Mass number, it is the sum of the protons and neutrons. Clear? And atomic number can be represented as Z. Okay. Then we are going to learn how to represent this atomic number and mass number in an element. So, in the notation for an atom with atomic number, mass number and symbol of the element are to be written as like this. First we write the symbol of the element. Okay. Symbol of the element. Then on the left bottom, okay, left bottom we write atomic number. Atomic number on the left bottom of the symbol. Then left top of the symbol we write mass number. Clear? So symbol of the element, then left top mass number, left bottom atomic number. It can be write like this. Z. Z means the symbol of the element. Consider X as the symbol of element. Then Z as the atomic number. Then atomic mass, that is A. Clear? In this way we can represent atomic number, mass number and symbol of the element. Clear? Everyone?
Yes, ma'am.
Yeah. So, hydrogen. What is the symbol of hydrogen?
H.
Yeah, it's H. What's the atomic number? Atomic number? Yeah, it's 1. Then what about mass number? That we already learned. Atomic masses of certain elements.
Ma'am, 1.
Yeah, it's 1. Very good. It's 1. So we represent hydrogen's atomic number, mass number and symbol like this. H, then left bottom 1 as atomic number, here left top mass number. Then next one, oxygen. How can we represent oxygen? What is the symbol of oxygen?
O.
Yeah, it's O. Then what about the atomic number?
8.
Huh? 8. Then what about the mass number?
16.
Yeah, it's 16. So we can represent all these elements in the periodic table like this, including its atomic number, mass number, then symbol of the element. Okay. Then next example, chlorine. Abin,
Yes, ma'am.
yeah, can you tell me the symbol of chlorine?
Cl.
Yeah, it's Cl. What about the atomic number?
17.
17. Then mass number?
Number 35.
Yeah, 35.5. Okay. So in this way we can write or we can represent element with atomic number and mass number. Clear, everyone? Any doubt regarding the notation of atomic number, mass number and symbol of the element? Okay, then we are going to learn the next topic, that is isotopes. Did you heard this term before? Yeah, isotopes. Yes or no? Did you heard this term before? Isotopes. Gerlin? Yes or no?
No, ma'am.
No. So it's a new term for you. So in the case of hydrogen atom, it has 3 atomic species. In the case of hydrogen atom, it has 3 atomic species or 3 varieties. It is protium, deuterium and tritium. Protium, deuterium and tritium. 3 atomic species of hydrogen. Okay. Then look at this image and the symbol. And tell me, what about the atomic number of protium? Karthik? Karthik, can you hear me? Karthik? Dominic, can you hear me? Dominic? Minha?
Yes, ma'am.
Yeah. Can you tell me what about the atomic number of protium? Look at this symbol and tell me the atomic number of protium.
Ma'am, 1.
Yeah, it's 1. What about the mass number?
1.
Yeah, it's also 1. Then the next one, deuterium. Look at this symbol and tell me, Sean. Sean, can you hear me? If you have no such issues, please switch on your videos. Shania, Justin, Srihari, Sovel, Fagad, Abin, Karthik, Kshetra, Said, Lakshmi Nanda, Minha, Dominic, Sean.
Ma'am, my camera is on.
Who's? But I can't see you.
Ma'am, network problem.
Okay, it's okay. Yeah. So, next one, deuterium. Okay, Dominic, can you hear me? Kshetra? Kshetra. Justin,
Yes, ma'am.
can you tell me the atomic number of this deuterium? The second one. Atomic number. H, 1, 2. Tell me. Ashi, can you tell me?
Yes, ma'am.
Atomic number of deuterium. Look at this symbol and tell me.
1.
Yeah, it's 1. What about the mass number?
Oh,
Yeah?
1, 2. Okay,
Yeah,
1.
no, 2. This one is the mass number. It's 2. Okay. Then the third example. Tritium. Emerin, can you hear me? Emerin,
Yes, ma'am.
please tell me the atomic number and mass number of tritium.
Atomic number is 1.
Yeah.
Tritium is 3.
Mass number is 3. Right? So, when we look at these 3 atomic species of hydrogen atom, atomic number is 1 in every species, but the mass number is 1, 2, and 3. From this, can you define a statement for isotope? Anyone? Their atomic number 1, 1, 1, same. And mass number is 1, 2, and 3. So, can you define any statement for this isotope?
And
Anybody? Yeah, Minha.
different in neutron number.
Difference in neutron number, that's fine. Can you define this isotope using this similarity and difference? Anyone? No? So we can define these isotopes as atoms of same element having same atomic number but different mass numbers. Okay. Isotopes are defined as the atoms of same element. Atoms of same element having the same atomic number but different mass number. Clear? When we look at these examples, everyone, protium, deuterium, tritium, atomic number is same, 1, 1, 1, 1. But look at the mass number, it is varying, 1, 2, and 3. This can be, this atomic number and mass number can be identified from the image itself. Look at this first image. Here one proton. One proton means its atomic number is 1. And there is no neutron here. So the atomic number is 1 and the mass number is the sum of proton and neutron. Here only one proton, no neutron. So its mass number also 1. Then next deuterium. Here one proton and one electron. It means atomic number is 1. And the mass number sum of proton and neutron. Here one proton, one neutron. So it is 2. Then the third example. Here the number of proton and number of electron, it is 1. So the atomic number is 1. Then the mass number is the sum of proton and neutron. Here 1 proton and 2 neutrons. So 3 is the mass number. So isotopes are the atoms of same element having same atomic number but different mass numbers. Then the 3 isotopes of hydrogen atom, protium, deuterium and tritium. Okay, protium, deuterium and tritium. And the chemical properties of isotopes, they are similar, but their physical properties are different. Chemical properties of isotopes are similar, but their physical properties are different. And look at these two examples. These two are the isotopes of carbon. The first one, what about the atomic number of both carbon? Anjali Priya. Atomic number. Yeah, 6. What about the mass number?
12,
Here it is 12 and then next one?
13.
13. Here also same atomic number but different mass number. So C612 and C613, these two are the two isotopes of carbon. Okay? Clear? Shall I move to the next one?
Yes, ma'am.
Yeah. Then the third example, chlorine. Okay? Chlorine occurs in nature in two isotopic forms. Chlorine occurs in nature in two isotopic forms. First one 35U, sorry. First one is 35U and the next one is 37U. Two isotopes of chlorine that occurs in nature. 35U means one atomic mass of first chlorine isotope is 35 and the next one is 37. And it exists in the ratio 3:1. 35U is more, 37U is least. Okay. If an element occurs in isotopic forms, then we have to know the percentage of each isotopic form and then the average mass is calculated. If this isotope occurs in nature in more than one form, we have to know the percentage of each isotopic form. It means how much. Here it represented in the form of ratio. From this ratio, we can identify that this 35U mass chlorine is more and 37U mass chlorine is least. So we know the percentage of each isotopic form to calculate the average mass. Okay. Then we have to calculate the average atomic mass of chlorine atom. Okay. The average atomic mass of chlorine atom. Then look here, how to calculate the average atomic mass of chlorine atom. First one, the isotopic atomic mass, that is 35. Then, do you know how this 75 by 100 came? How this 75 by 100 came? Anybody can tell me? How this 75 by 100 came? Any idea? Here the ratio is 3:1, right? It's for 35U and it's for 37U. Okay. Then when we consider this total as 100, the 3/4 part of 100, it is 75 and the one part, that is 75:25, right? That's why here we take 75 by 100, then plus 37. That's the next isotope into 25 by 100. Then we will obtain 35.5U. That's the atomic mass of chlorine, right? So this chlorine atom, it already exists in nature in two isotopic forms. First one is 35U atomic mass, then the next one is 37U. Then we have to calculate the average mass of this chlorine atom by combining these two in the form of this equation or this. After this calculation, we will obtain this average mass of chlorine atom. Clear? Any doubt? Anybody? Okay. So, we will obtain this value 35.5U as average atomic mass. This does not mean that any one atom of chlorine has a fractional mass of 35.5. Okay, it doesn't mean that 35.5. It means that if you take a certain amount of chlorine from the nature, it will contain both isotopes of chlorine, but the average mass is 35.5. Means there will be 35U and 37U, but the average mass of this chlorine atom is 35.5 U. Clear? So we learn isotopes. They have atoms of the same element having same atomic number but different mass number. Examples for these isotopes are in the case of hydrogen, protium, deuterium, tritium. Then we learned the example of carbon, C612 and C630. Then we learned chlorine, chlorine 35 and chlorine 37. Okay, fine. Is this clear for everyone? Yes or no?
Yes, ma'am.
Yeah. Then the next one, applications of these isotopes. Okay, there are certain important applications for certain isotopes. An isotope of uranium. Uranium is an element and it is a radioactive element. Okay, radioactive element. It means it can emit radioactive waves. So an isotope of uranium, it is used as a fuel in nuclear reactors. Did you learn this nuclear reactors in physics? Nuclear energy? Yes or no?
Not yet.
Not yet. Okay, fine. This nuclear reactors, say type of plant that is able to produce nuclear energy. So here, the isotope of uranium, it is used as a fuel in such nuclear reactors. Okay, that's the first important application of an isotope. Then the next one, isotope of cobalt. Okay, cobalt is an element, it is a metal. And this isotope of cobalt, it is used in the treatment of cancer. Okay, used in the treatment of cancer. This cobalt, cobalt 60, that's the actual isotope, cobalt 60. It is used as the radioactive, we know that there are certain radiations for the treatment of cancer, right? So we are using this cobalt 60 as the radioactive source for the treatment of cancer. That's the second important application. The third one, it is the isotope of iodine. Okay, isotope of iodine. It is used in the treatment of disease goiter, something related to thyroid. Okay, goiter. And these three are the important applications of certain isotopes. So, Abin, can you read these three applications?
Applications.
Yeah.
An isotope of uranium is used as a fuel in nuclear reactors.
Okay.
An isotope of cobalt is used in the treatment of cancer.
Yeah.
An isotope of iodine is used in the treatment of goiter.
Okay, fine. These three are the important applications of certain isotopes. Okay. Shall I move to the next one?
Yes, ma'am.
Yes, ma'am.
Yeah. Then there will be one more topic, that is isobars. Anyone can define isobar? We already learned isotope, the same atomic number but different mass number. And can you guess any definition for this isobar? Anyone? Anybody? Please guess.
Same atomic weight.
Who? Yeah, Minha, tell me. Same atomic number. Minha, try. Isotope is same atomic number but different mass number. Then isobar?
Ma'am, more isotopes.
Huh?
More isotopes.
More isotopes. I give a clue that isobar is something just opposite that to that of isotope.
Same atomic number and mass number.
Just opposite to that of isotope. Isotope is same atomic number but different mass number. So isobar is?
Same mass number and different atomic
Very
number.
good. Same mass number but different atomic number. So let us consider these two elements, calcium and argon. Calcium. What about the atomic number of calcium? Tell me. Calcium
20.
yeah, it's 20. Sorry, it's 20 atomic number. The next one, argon. What about argon atomic number?
18.
Yeah, it's 80. But these two have a common mass number, that is 40. Okay. So let us consider these two elements, calcium atomic number 20 and argon atomic number 80. The number of electrons in these atoms is different and they are different elements, right? But the mass number of, sorry, this is both. Okay. Both these elements is 40. So the total number of nucleons is the same in the atoms of this pair of elements. So we can define isobar as atoms of different elements with different atomic numbers which have the same mass number are known as isobars. Clear? Atoms of different elements, different atomic number but same mass number. It means the nucleons, that means the number of protons and neutrons. The sum of the number of protons and neutrons is same. Okay, this one is an example for this isobar, calcium and argon. The potassium is also an example. Okay, potassium also K, it's 19, its at mass number is 40. So these are the examples for isobars. So isotope and isobar, isotope atoms of the same element having same atomic number but different mass number. Isobar atoms of the different elements with different atomic number but same mass number. Everyone clear? Yes or no? Any doubt? Any doubt? Nothing? Okay, that's about this
Ma'am,
chapter.
can you,
Lakshmi, any doubt?
ma'am, can you show that last point once
Yeah.
more?
Sure.
Slide.
That's about this chapter. So there are certain questions remaining to write in your notebook. That's page number 50, 2 questions. Then page number 52, 2 set of questions, and page number 53. The remaining textual questions you have to write into your notebook. Okay? We just write 2 sets of questions, right? Page number 47 and 49. Then you need to write the remaining questions and I will send you the notes and the textual, the exercises behind this chapter. Also, I will send you through the WhatsApp. And we have to discuss, I told you that the major portions of the first chapter is deleted, but there are certain points remaining there to discuss. So we can discuss those topics in the next class. Okay? Everyone? Okay, then let me take your attendance. Abin present. Akhlam Fatima. Elna Rose. Ananda Krishna. Anjali Priya. Anthony Maxi. No. Arun Bhaskar.
Present, ma'am.
Yeah. Ashik Joshi. Present. Adulya present. Bastin. Bastin was there in the beginning. Okay. Devasena. Present. Dominic. Present. Elsa. Elsa. Amarin.
Present, ma'am.
Present. Fagat. Gauri Nandana. Present. Gaudam. Jerlin. Present. Jaslin. Jaslin. Justin. Present. Karthik. Present. Kshetra. Present. Lakshmi Nanda. Present. Melita. Present. Minha. Present. Revu. Said, present. Sania, present. Shania, present.
Present, ma'am.
Sean, present. Sovel,
Present, ma'am.
yeah. Sriram, no. Srihari, present.
Yes, ma'am.
Swati, present. Okay. So, all of you write the questions in your notebook. Study well. Okay. Thank you all. See you next class.
Thank you, ma'am.
ma'am.
Bye.
Thank you, ma'am.